Today we're going to talk about how hydrogen was discovered. If you look on the periodic table, you can see that every element is numbered in order from 1 to 118. The first element on there is hydrogen. Hydrogen is number 1 on the periodic table. It is the lightest element. It is defined by having a single proton and a single electron, usually. There are a few isotopes of hydrogen. It could have 1 neutron in the nucleus, or it could in fact even have 2 of them. Hydrogen is important because it is the lightest element, and it is the first one that ever existed in our universe. It's the most abundant. Over 70% of our entire universe is made of just hydrogen alone. Hydrogen turns out to be a very interesting element when you consider all the technological revolutions of the past few years. We've been using the idea of hydrogen to fuel fusion reactors, which is essentially our way of making limitless energy for all of humanity. Hydrogen also has a place in clean vehicles. You can use cells made of hydrogen to power electric vehicles. The knowledge of what hydrogen is and where it is and what it looks like is obvious to most of us. We're taught in middle school what hydrogen is. Everybody knows about it. But it's important to remember that there was a time where people didn't know about hydrogen. People had no clue. Nobody had any idea of what it was. Somebody had to figure out what it was, and then other people had to verify those findings. The scientific community had to be made aware of the existence of hydrogen. Nobody told them about the existence of this element in school. They had to figure it out through observations and experiments. And that's exactly what they did. In the early days of chemistry, people would just kind of throw chemicals around and just see what happened. That's most of the work that occurred. They would record their observations and they would take measurements. It was a very disciplined kind of science. But there was a lot of seemingly random experimentation. The discovery of new materials, new gases, and these properties of these materials and gases, they had to be worked out in a laboratory. They had to be discovered, seemingly by accident. Because of all the very intelligent scientists who ran these experiments and did these tests and asked the important questions, they are the reason that we have the world we live in today. The internet that I'm using right now to talk to you was discovered and was built on observations of people who just had an extreme amount of curiosity and ran a bunch of experiments. It would be an understatement to say that we owe a tremendous amount of gratitude and respect to the people, the scientists who gave us what we have today. Without them, we would still be cavemen. We would still be a primitive society. The internet wouldn't happen. Medicine wouldn't happen. Cars and roads and cryptography, these things wouldn't exist. They would have no chance of coming. Because people asked questions, because people made observations and ran experiments that were seemingly random, these people are the reason that we have the world we live in today. We have to remember that. We have to be grateful. And we have to make sure that we carry on that legacy. We have to carry on that attitude so that we can continue moving forward. Generations from 100 years from now or 1,000 years from now will benefit from the things that we, our generation, our world discovers and adds to the scientific knowledge. Because the advancement of humankind depends on having a tremendous amount of our human resources dedicated towards discovery and towards science. One of the first people that noticed hydrogen and its properties was Robert Boyle. He was a very, very influential chemist who even has a scientific law named after him, Boyle's Law, which is still used by chemists all over the world today. Boyle ran laboratory experiments where he would mix hydrochloric acid with steel filings. When he mixed these, he noticed that they would bubble and release heat, and some gases would form. Boyle asked the question, what happens if flame was held to these gases? Boyle would take a candlestick and hold it to the mouth of the vial that he made this compound in. And he noticed that all of the gas inside of the vial would combust in this greenish bluish flame. It turned out that Boyle had created hydrogen gas. He also made ferric chloride, but we don't care about that right now. What matters is that there is now recorded evidence of a flammable material, a novel gas being created from the mixture of acids and metals. Boyle was not able to isolate this gas any further or test its properties, but it's pretty cool that he was able to make these observations and kind of be the first form of detection for what would later turn out to be hydrogen gas, something so fundamental to chemistry today. If you were to look up on any search engine, who was the discovery of hydrogen, you're usually going to get the name of the British chemist Henry Cavendish. Henry Cavendish was a very, very smart scientist. He made a tremendous amount of contributions. Our understanding of physics and chemistry was significantly pushed forward thanks to his involvement. Cavendish did a lot of things, and discovery of hydrogen is one of those things. One of those very important things that he contributed. The way that Henry Cavendish went about creating this was the same way that Boyle would do it. He made hydrogen gas by mixing steel filings with acids. If you know anything about chemistry, you know that an acid mixed with a metal is almost always going to make water, some sort of salt, and definitely hydrogen gas. Cavendish also observed how the gas that was created with this reaction would ignite. He actually, in his papers, would refer to it as inflammable air, mostly because it burnt. However, Cavendish gave this gas a lot more attention than Boyle had before. One of the notable experiments that he did was that he would create this gas and isolate it in a flask that was sealed. He would then hold flame to the gas and observe what kind of energy it gave off when it was ignited. Cavendish observed, at first, a mixture of mostly common air, which is just regular air that you could find all around you, mixed with this hydrogen gas. It would be mostly common air and a little bit of hydrogen. When Cavendish ignited this mixture, he would notice a small, subtle, weak flame. And then Cavendish did the experiment again, except this time he would include a little bit more hydrogen and a little less of the common air. He repeated this step over and over and over, and he found that the more hydrogen he added, the more energy would be released by the combustion. With each time he did the experiment, he noticed more and more heat would be given off, and the noise created by the reaction would be louder and louder. The flame inside of the vial would burn quicker and quicker. It would be a shorter, quicker, hotter, brighter flame. This pattern continued until he got to about a 50-50 ratio. In his papers, it's actually about 6-4. It's about 6 times common air to 4 times of hydrogen gas, or inflammable air as he knew it. And then the pattern went the other direction. He did a 50-50 mixture, and it was essentially the same as the 60-40 mixture. And then he would add mostly hydrogen gas with just a little bit of common air, and the pattern would completely reverse. Cavendish would notice that the flame would be incredibly slow. It would burn a lot less quickly. It would have less energy, it would give off less light, and it would have a weaker sound to it. Cavendish didn't know it at the time, but what he was doing was allowing the hydrogen gas and the oxygen gas and the common air to react with each other. The energy of the flame was enough to spark a quick automatic reaction that would set off a chain and create H2O, water vapor. Another set of experiments that Cavendish did was that he would attempt to make inflammable air with different reactions. We said before that if you mix an acid with a metal, it is almost definitely going to create hydrogen gas. We know this now because Cavendish would create hydrogen gas with different acids and different metals. Each time he would notice that the same gas with the same qualities would be created. Each time he added any metal filings to a vial of acid, it would give off heat, it would give off bubbles, and it would give off this inflammable air. When we say that Cavendish was methodical, we mean it. He really was methodical. He even was able to measure the density of this gas as compared to regular air. He would take a bladder, whatever it looked like, I'm not really sure, I don't know. Some sort of container to where he could fill it with gas. He would fill it with regular air, and then he would weigh it on a scale, and then he did the same thing with hydrogen gas. He can see the difference in weight and then compare their densities. By doing this Cavendish found that this hydrogen gas was 7 to 10 times lighter than regular air. And that's pretty close to what is actual reality. Hydrogen gas turns out to be 1/14 the weight of common air. But perhaps the most notable thing that Cavendish discovered was that any combustion of this inflammable air with common air would create water vapor. And that water vapor, allowed to condense, would form liquid water. Cavendish was one of the first scientists to notice this, and it was an incredible discovery. This seemingly fundamental gas that could be created through a multitude of different reactions can be combusted with regular air to create water, something so fundamental and abundant on the earth. Cavendish was the one to discover that regular liquid water was simply a mixture of regular air and this hydrogen gas that he created. This is actually the primary reason that we named this gas hydrogen. If you notice, hydrogen can be split into two parts. Hydro, meaning water, and gen, meaning creation. Water creation. Hydrogen gets its name because it can be burned with oxygen to create water. And we owe this very fundamental discovery to Henry Cavendish. The modern fields of engineering and science that take up our academic world are highly advanced compared to how they were in Cavendish's time. But we wouldn't be anywhere near where we are unless we took those first steps, the first discoveries that were made by scientists like Henry Cavendish. These days, there's a tremendous amount of research into how we can utilize hydrogen to power our cities, to power our cars, to even power future spaceships. Hydrogen is a fundamental element that is one of the most important materials utilized in modern science. There is a tremendous amount of work to do to understand the very fundamental nature of matter and particles. Hydrogen usually takes the stage in all of the experiments that we do in modern research. As we do these experiments, as we ask these questions, and we expand our technology, we have to remember that we owe so much to scientists like Henry Cavendish for making these very fundamental yet very important discoveries. This was the discovery of hydrogen. If you enjoyed this video, please leave a like and subscribe. If you would like to see any other topics covered on this channel, please go ahead and leave a comment down below. Thank you for watching.